All right, welcome back to the deep dive. Today we're diving into something pretty electrifying, if you will, electricity itself.
Hey, I see what you did there.
Oh, it had to be done.
Well, on all seriousness, yeah. Electricity, it's everywhere. It powers our lives. And we all need to understand it better, especially the safety aspects.
Exactly. And for this deep dive, we've got a bunch of materials covering the basics of how it works, what makes it dangerous, how to stay safe, all that good stuff.
Right. We'll be breaking down things like voltage and current resistance and, getting into the nitty-gritty of electrical shocks, burns, even arc blasts. And we also have some OSHA safety guidelines in the mix, which is always important.
Yeah, those are key. So our goal today is to give everyone a solid understanding of the hazards without, overwhelming anyone with the super technical stuff.
Right. We want to keep it clear and practical. So maybe a good place to start is just, well, what is electricity? Like, at its core, what are we talking about?
Okay, yeah, good point. What is this mysterious force?
Well, think of it as energy. Energy created by charged particles, tiny things called electrons, moving through a conductor. You can imagine it like water flowing through a pipe. That kind of gives you a visual.
Okay, so the electricity is like the flow.
Yeah.
But how do we measure how much is flowing and how forcefully?
Right. So that's where we get into current and voltage. Current, measured in amps, short for amperes, is basically the amount of those electrons passing a certain point at any time. Like if you think about the water analogy, it's like the volume of water flowing.
Makes sense. So what about voltage then?
Voltage, which we measure in volts, is the force that's pushing those electrons along. So sticking with our water analogy, it would be like the water pressure.
Okay, I think I'm following so far. And we have resistance too, right? Measured in ohms.
Yeah.
That's basically like the friction slowing the flow down, yeah.
Exactly. Resistance is anything that opposes the current. And all three of these, current, voltage, and resistance, are related by a neat little formula called Ohm's law. Basically, it says current goes up with higher voltage, but down with higher resistance. Pretty intuitive when you think about it, right?
Yeah, it is. So electricity always wants to flow, and it needs a complete path to do it. That's a circuit, right?
Absolutely, a complete loop. And here's the kicker. Electricity always wants to take the easiest path to the ground, which unfortunately is where the danger for us humans comes in.
Yeah, because we can become part of that easy path, can't we?
Unfortunately, yes. We call that an electrical shock. It happens when our body becomes part of that electrical circuit. There are a few ways this can happen, like touching a live wire and a neutral wire at the same time, or touching a live wire while you're grounded.
Oh, and I guess also if you touch something metal that somehow become energized, right? Like a faulty appliance or something.
Exactly. And one of the most important things to remember here is it's the current, not necessarily the voltage, that's really dangerous to our bodies.
Yeah, our research showed even small amounts of current can do some serious damage.
It is kind of scary how sensitive we are to it. Like, just a few milliamps can cause muscle contractions. That's why people sometimes can't let go of a live wire. Their muscles just seize up.
Right. And then at higher levels.
Well, if you get around 100 milliamps flowing through the heart, that can disrupt your heart rhythm, leading to something called fibrillation. And that can be fatal, really quickly.
So it's not just about fatal shocks either. Even non-lethal ones can be really painful. Throw off your balance, cause muscle spasms. You could fall and hurt yourself too.
Absolutely. So many risks. That's why knowing what to do in case of a shock is so important. And the first rule, always, is don't touch the person if they're still in contact with the source of electricity. Got to cut the power first, or use something non-conductive to move them away.
Right, like a broom handle or something.
Yeah.
And if their heart stopped, every second counts to start CPR.
Absolutely. Those first few minutes are critical. And, another thing people might not realize is that if your skin is wet, it actually reduces your resistance to electricity. So even low voltage can be really dangerous then.
Yeah, like if you're standing in water or something. Yikes. And we should talk about burns, too. Those are another hazard of electricity, right?
Definitely. Burns can happen directly from the current passing through you, or indirectly from the heat generated by the electricity, like say a wire gets super hot.
And we came across this term, arc blasts. Those sound pretty intense.
Yeah, those are serious business. An arc blast is basically when a high current jumps between two conductors. Often happens during switching or even from static discharge. It's basically like a mini explosion, can be super hot and loud.
Whoa, okay, so there's a good reason why electricians always tell you to use your left hand for switching stuff on and off, right?
Yep, keeps your face a bit further away. And another good tip, always disconnect the power before you start messing with any switches or connections.
Makes sense. And we should also talk about fires and explosions. I mean, those are probably the most obvious dangers people think about with electricity.
Right, and they're a real threat. Overloading circuits is a common cause of fires. When you plug in too much stuff on one circuit, the wires heat up, the insulation can melt, and boom, anything flammable nearby can catch fire.
And I'm guessing in places with flammable materials, even a small spark could set things off, right?
Absolutely. Think like workshops with sawdust or areas with fumes. Sparks can be disastrous in those environments.
So let's talk prevention. What are the most important things people need to know to stay safe around electricity?
Well, the golden rule is to always disconnect the power before doing any kind of electrical work and use lockout tagout procedures to make sure it stays off while you're working.
Lockout, tagout, what's that exactly?
Basically, it's a system where you physically lock the power switch in the off position and put a tag on it that says why it's locked out so no one accidentally flips it back on while you're working. Super important.
Got it. So what else? Don't wear jewelry, right?
Right, no metal jewelry near electrical circuits. And always use non-conductive ladders and insulated tools. You don't want to become a conductor yourself.
Right, right. And in places with a risk of explosion, you need those special explosion-proof lights, correct?
Exactly. Those are designed so they won't ignite any flammable gases or vapors. And another important concept is grounding.
Grounding. We hear that a lot. What does it actually do?
So grounding basically gives stray electrical current a safe path to the earth in case of a fault. It'll trip a circuit breaker or blow a fuse, preventing that current from flowing through you. Think of it like a safety valve.
Okay, that makes sense. And some of the safety advice seems pretty basic, like don't overload your outlets, make sure wires aren't damaged.
Yeah, those are simple but crucial. Don't run wires under rugs or through doorways where they can get damaged, and replace any frayed or exposed wires right away. If you have to temporarily insulate a wire, make sure you use proper electrical tape, not just duct tape or something.
Speaking of, we should talk about fire extinguishers. Which type is the right one for electrical fires?
Never use water on an electrical fire. You want a Class C fire extinguisher, which uses dry chemicals or CO2 to put out the fire.
Okay, good to know. And I know we also came across some specific OSHA regulations about electrical safety at work.
Right. OSHA has a whole bunch of standards to make sure workplaces are safe when it comes to electricity. They cover everything from making sure equipment is properly approved and labeled to having enough clear space around electrical panels.
So how much space are we talking?
Well, for equipment up to 600 volts, you generally need at least 30 inches of clear space in front of it. More if it's higher voltage. And they have rules about lighting in electrical rooms, making sure there's enough headroom, even color coding wires so you can tell which is live, neutral, and ground.
Yeah, the color coding makes sense. And what about on construction sites? Are there special rules there?
Definitely. On construction sites, most outlets need to have GFCIs, which stands for ground fault circuit interrupters. They basically shut off the power super fast if they sense a ground fault, helping prevent shocks.
Okay, those are important. So OSHA also has rules about handling batteries and using personal protective equipment, right?
Yep. When you're dealing with batteries, especially the big ones, you gotta wear eye and face protection, gloves, even a plastic apron. And when you're adding acid, always add the acid to the water, not the other way around. It can splash and cause burns.
Oof, yeah. And what about if you do get an acid burn?
Flush it with lots of water right away for like 15 minutes. Better safe than sorry. And for general electrical work, you always want to have your PPE on. Non-conductive head protection, face shield or goggles, insulated boots, insulated gloves, and insulated tools.
Right. So the big takeaway here is that electricity is powerful stuff, and we need to respect it. Understanding how it works and the dangers involved is crucial for everyone, not just electricians.
Absolutely. I mean, we rely on electricity for so much these days, so knowing how to stay safe around it is just essential.
Totally. It's something everyone should be aware of. And that brings us to a final thought for our listeners. As we get more and more reliant on electricity, and with all the new technologies coming out, what's our collective responsibility as individuals and as industries to make sure electrical safety keeps pace?
That's a great question to ponder. It's not something we can just take for granted. We need to be proactive and informed to make sure we can all enjoy the benefits of electricity safely.
Absolutely. Well, on that note, that wraps up our deep dive into the world of electricity. Thanks for listening, everyone.
Thanks for having me.